let's discuss how we get a compound angle. See, when I say compound angle, this particular derivation, what we are going to do, it's quite important. We are looking at cos of x plus y. So here we are adding two angles and we are trying to figure out what is the result. All right. So for this, look at this particular figure. Now you have a circle. Now the center of the circle is at origin. Fine. Say the point, let's call this as, this is O, 0, comma 0 origin. Say this point is A. This is 1, comma 0. That means it's a unit circle. Fair enough. Now what we'll do, we'll take a point, some point here. Say this point is B. All right. Now A to B across the arc of the circle, in the sense across the circumference of the circle, say the distance is x. In the sense here, this distance what we are looking at, this entire thing is x. Fair enough. Now since this value is going to be x, now what we'll do is we are going to take a small value. So value in the sense we are going to take a line and we are going to join. So from here to origin, join this. All right, see, once you join this, the angle, this particular angle is going to be x. Make sense? Now what we'll do, so we'll take another value, some other point, say some point here, we'll take it as c. Now we are taking it in such a way that from B to C, this value is y. Once you have marked point C, now this is y, correct? Then what we are going to do, so we are going to join from O to C. Okay, or let's make it in the same color so that it's much easier for us. So what we'll do, we'll join this O and C. Clear? See, the next thing what we have, do not join B and C. Now, what is this angle? Now, remember this angle what we are looking at, this is angle Y. Correct? The same logic as what we did. The next thing what we'll do, we are going to mark another point, but in the clockwise direction. Remember, anti-clockwise is positive, clockwise is negative, correct? So what we'll do, we'll mark a point somewhere over here. Say we are going to take some point here, say this point is D. Okay. Now, once you have point D, now what we'll do, so we'll join this D to point O. See, we are going to take this one. Like this, we are going to join. Okay, so we are joining in such a way that this angle is minus Y. Minus Y. See, now what we are going to get, this is a very, very important step. What are the coordinates of A, B, C, D? Very, very important. Okay, here, if see, point A is 1, comma 0, that's very clear, very easy. Now, point B, okay, whatever we have now, point B. So, this particular point B, we can write the coordinates of point B as cos of x, comma sine of x. Now, how do we get cos of x and sine of x? This is the next point. See, to understand why we get this, always the x coordinate is given or represented in terms of cos theta, and y coordinate is always represented in terms of sine theta. So point C is going to have cos of x plus y, comma sine of x plus y. All right. And point D is going to be cos of minus y, comma sine of minus y. The angle is minus y, right? That's why. Clear? Now what we'll do, we are going to complete this into a triangle. In the sense, what we'll do, first we are going to join this point B and point D here. Okay, so first we'll join this. See, this is one triangle. Then after this, we are going to take point A and we are going to take point C. This one also. Okay, here we are going to make this as one more triangle. Now we have two triangles and we are going to make use of these two triangles, use distance formula and all these things. Clear? This is the basic thing about this particular derivation. Alright, now let's derive it. Now that we know what are the coordinates, we'll use these coordinates and we'll calculate what is it. Alright, look at the two triangles. The two triangles what we'll consider for now is, say we are going to take triangle, first is AOC and triangle BOD. When you take these two triangles are congruent to each other. Because think about it. Look at the angle, the central angle. Central angle is the same and the sides are also same. In the sense, if you look at these two triangles, AO is equal to BO, radii, correct? And also CO is equal to DO. These two are equal because they are radii of the same circle. Central angle, that is angle AOC. Angle AOC is this entire angle. This angle is equal to angle BOD. Correct? You are going to get this. That means what do we say? We say that triangle AOC is congruent to triangle BOD. Isn't it? SAS congruency. Since they are congruent to each other, the corresponding sides are equal. That means we can say that AC is equal to BD. Now this is a very important conclusion. AC is equal to BD because we can use distance formula. We know the coordinates of A, B, C, D. We can use that and we can figure out what is the value. Okay, that's what we are going to do now. We'll use distance formula and we'll figure out what is what. Fine. Now let's calculate what is AC and BD distance by using distance formula. For AC, see you have AC. This distance is equal to what is C? C is cos of x plus y, comma sine of x plus y. And point A is 1, comma 0. So AC is going to become 1 minus cos of x plus y whole square plus 0 minus of sine of x plus y whole square. Now this is under the root, correct? Distance formula is under the root. Now when you equate AC and BD, both of them are root, we can cancel it out. Okay, so for now we'll just write it this much. Now what are you going to get here? You'll get 1 plus cos square x plus y minus 2 cos of x plus y, correct? Then plus sine square of x plus y. Now here I want you to notice this. What is this? What is cos square of x plus y plus sine square of x plus y? 1, right? So what we can write here? We can say 1 plus 1, 2 minus 2 cos of x plus y. Or you can say, just take it as 2 minus of this one. Call this as equation number 1. Okay, remember this is equation number 1. 2 minus 2 cos of x plus y. Now we calculated AC. Next we'll calculate what is BD. Alright. Now BD. So BD is going to become, now B is cos x and comma sin x, and D is cos of minus y sin of minus y. Now BD is going to become cos x minus cos of minus y is nothing but cos y itself. So cos x minus cos y whole square plus sin x minus of, what is sin of minus y? Minus sin y, isn't it? So this is going to become plus sin y whole square. So you will get cos square x plus cos square y minus 2 cos x cos y plus sin square x plus sin square y plus 2 sin x sin y. Again, if we group it, see this is 1, this is also 1. So 1 plus 1 becomes 2. Now what we have, we are going to get 2 minus 2 cos x cos y plus 2 sin x sin y. Now call this as equation number 2. We equate 1 and 2 because AC is equal to BD. Again, I'll tell you the under the root. This actually is under the root. The whole root we can cancel it out when we square both of them. So just equate one another. Alright, so we are equating equation 1 and equation 2 now. Equation 1 is equal to equation 2. So we have 2 minus 2 cos of x plus y is equal to 2 minus 2 cos x cos y plus 2 sin x sin y. Now the 2 and 2 gets cancelled. Here, see, you can divide the whole equation by minus 2. So if you do that, like if you're dividing it, then we are going to get a value cos of x plus y when you divide by minus 2. Cos of x plus y is equal to cos x cos y minus sin x sin y. So this is the formula for cos of x plus y. So cos of x plus y is equal to cos x cos y minus sin x sin y. Fair enough? Now, whatever the derivation we have done, it's quite important. Now, with the help of this derivation, we can derive a lot more. We can derive cos of x minus y, sin of x plus y, sin of x minus y, tan of x plus y, x minus y. A lot more formulas we can derive with the help of just this one. And also, in the previous videos, we have learnt about allied angles, like sine of 90 plus theta, cos of 90 plus theta, or any of those things. Those things can also be figured out. Like we can use this particular identity, the compound angle identity, and we can get those values. All these things we'll discuss in the next video.